Hello everyone, my name's Alex Karim. I'm an Azure go-to-market manager here in the UK, and I'm here to talk to you about Azure Quantum today, which is a really exciting innovation workload within the Azure portfolio of technologies. And ultimately, when we talk about quantum, if we take a step back, I mean, if we think about the world, as it were, like, we're living through a time of rapid technological change. There's no way to kind of put it in any other terms. Ubiquitous computing is everywhere, and technology is transforming every aspect of work and life. But at the same time, there's still so much left to discover and progress to be made. Hidden in the mysteries of nature, as it were, are the answers to some of the most complex problems facing society today, whether that's food sustainability, mitigating climate change through things like carbon capture. But even with all the computing on the planet right now, scientists still haven't been able to solve all of these challenges. We haven't been able to understand, control, and model the complex interactions that happen and are governed by quantum mechanics, subatomic interactions. Um, and understanding natural processes is pretty important. 96% of all manufactured goods today rely on chemicals or chemical manufacturers. And also understanding these natural processes, these quantum mechanical interactions, is really at the core of advancing chemistry and material science, because it impacts every aspect of our daily life. From the Iron Age revolutionizing, agriculture, to the Silicon Age revolutionizing how we communicate and connect, new materials have always created inflection points for societal progress. And the path from idea to breakthrough, it really is mind-bogglingly complex. Developing a true understanding of nature is not an easy task. Scientists must sift through infinite combinations of nature's building blocks, as the number of possible stable molecules is believed to far surpass the number of atoms in the universe. The arrival of digital computers has been a game changer for simulating smaller molecular interactions, but the technology hasn't yet met the demands of the sheer scale and complexity of chemistry and material science problems. And at Microsoft, we've long understood the promise of quantum to help us understand and unlock these mysteries of nature, but the world really needs quantum at scale. Our aim really with Azure Quantum is to enable researchers to accelerate the next 250 years of chemistry and material science into the next 25 years. And that's our mission. That's ultimately what the team globally is working to do. And one of the first kind of steps on that journey really is with Azure Quantum Elements, the first of its kind comprehensive system for computational chemistry and material science. Quantum Elements will empower scientists with our latest advancements in supercomputing and AI, applied to the language of nature, quantum chemistry, and it can apply to scientific discovery and commercial industries. And we have many customers already using this today, which I'll talk a little bit later. Also, in as well as the technology that's available today, we are working on engineering, a quantum supercomputer. And I'll talk about Microsoft's unique approach to engineering a computer or quantum supercomputer a little bit later in this presentation. And then also, there is that kind of halfway house where we have elements through quantum elements that are available today. We are working on a fully fledged quantum supercomputer as well. But we need to make sure that our kind of ecosystem is ready for when that quantum supercomputer is ready. And we can't wait. We need to start building and enabling an ecosystem today. And that's a little bit as kind of one of the other three pillars that we'll be talking about. So if we talk about today, really an R&D paradigm shift is emerging, with computation as the partner in crime, as it were. When organizations accelerate research, they save time and money and ultimately deliver new products to market quicker and more responsibly. Businesses know that they are eager to accelerate their R&D pipelines for this exact reason. And if we're going to compress the next 250 years of chemistry, material sciences, the next 25 years, as I mentioned, we need a new R&D paradigm shift. And so instead of starting with intensive wet lab experimentation augmented by digital simulation, we can start with the computational simulations at large scale that will predictively guide our lab experiments. So these shifts are now possible because of our massive investments in innovation and hyperscale cloud AI and our progress with quantum computing. And it's really the integration of these three elements of the HPC, high performance compute, AI, and quantum computing together. Classic cloud services like HPC and AI serve as the on-ramp, to quantum computing, creating a continuum of compute power that in the cloud evolves and advances over time. And it's important to remember that scaled quantum computers will not replace classical computers, but rather complement and integrate with them, creating hybrid architectures that leverage the best of classical computing and quantum. And with these advances, we're now able to deliver specialized systems to accelerate scientific discovery, which kind of leads me to Azure Quantum Elements, accelerating scientific discovery so that organizations can bring innovative products to market more quickly and responsibly. And it's a system that empowers researchers effectively to make advances in chemistry and material science at speed, at scale, and importantly, accuracy by integrating the latest breakthroughs in HPC and AI and quantum computing together. And there's three kind of key points which I've kind of alluded to, which is scale, speed, and accuracy. With quantum elements, organizations are bringing products to market faster with state-of-the-art R&D capabilities enabled by high-performance computing and workflow automation on the cloud. Organizations can expand research horizons by accelerating calculations, which is the speed, by predicting molecular and material properties using custom AI models and cloud integrated workflows. And importantly, the accuracy. Researchers can solve the most challenging chemical material science problems with flexible tools that lay the groundwork for harnessing the power of scaled quantum computing. You can augment scientific discovery and increase your research productivity for some of the most complex chemistry and material problems with Copilot, a natural language interface integrated within your cloud environment for smart code generation and data connectivity, effectively bringing that Azure AI, the Copilot, into quantum to kind of accelerate things, faster innovation cycles with Copilot within quantum elements. And the productivity is really the key. We've had customers that are using this within their research today that are seeing projects that would normally take 6 months with traditional means actually reduced down to 1 week. And this is really what quantum is all about: reducing time to market for manufacturers and also chemical scientists and material scientists. That's really what it is. It's streamlining that research and development life cycle. And just Copilot in Azure Quantum, I'll just quickly kind of flash up a couple of slides on this. But ultimately, it's empowering scientists to reason through some of the most complex chemistry and material science problems and use natural language to help accomplish those tasks. It can generate underlying calculations, simulation, query, and visualize data, and also help scientists get guided answers to complex concepts, all of it integrated seamlessly into the existing tools that researchers have access to today. And finally, on quantum elements specifically, we have we've built these capabilities alongside scientists and researchers. It's not something that we've built and then brought to the market. It's something that we built in collaboration. About a year ago, we started quietly working with leaders in chemistry and material science to learn about their needs, exchange ideas, and collaborate on experiments together. And these learnings are ultimately what have now reflected in the system itself. And those industry leaders are among the first customers who are using Azure Quantum Elements today. And if I just call out one, in the UK, Johnson Matthey, massive material science background and manufacturing, Ultimately they've seen a 50% increase in speed, in some of their chemistry calculations with either HPC, AI, and quantum elements. And that's really what we're talking about: accelerating R&D to bring products to market faster and solve, obviously, some of the biggest problems on the planet. And I think that, when we talk about, quantum elements, if you have material scientists on staff in any form, quantum elements is available for your scientists to get hands-on with. Registration for the private preview is open, and there are also Azure credits to help you get started, which I'll talk a little bit about later on. So that's that first phase. It's what can we do today? We have the elements, quantum elements, to kind of help you get started. But also at Microsoft, our second ambition is accelerating, scientific discovery by building and engineering a quantum supercomputer to solve problems that are interactable, or even, or just not possible on the world's most powerful classical computers. And the path to quantum computing is not unlike the path that today's classical supercomputers have taken. The pioneers of early supercomputing machines had to advance the underlying technologies to improve performance before they could scale up to larger architectures. And that's what motivated the change from vacuum tubes to transistors and then integrated circuits. Today, we are in the equivalent of the vacuum tube era for traditional computers. Fundamental changes to the underlying technology will also clear the way for a quantum supercomputer. The industry will undergo 3 levels to achieve this, and I'll kind of talk a little bit about that later on in the presentation. Today's qubits, and before I kind of go into too much on qubits, a classical computer runs on ones and zeros, binary, right? That's, it's kind of on off, and they're the kind of 2 states. But as you know, with quantum as a term, the idea with quantum superposition is that a particle can be in multiple states at the same time, and that's what these qubits effectively represent. They're not just binary, 0 or 1. They can be in many states at the same time. The problem with qubits today is that they're still too noisy for us to reason and get the correct result from them. And that makes them very difficult to use to solve any practical kinds of problems. Today's industry, the noisy intermediate scale of quantum, NISQ, is kind of the foundational level when it comes to quantum computing. And while these are still not applicable to real problems, they're providing the foundation to start experimenting with quantum tech. And the Microsoft has brought the world's best NISQ quantum hardware to market today, with the highest quantum volumes in the industry, and all on the Azure cloud, so customers can start becoming quantum ready. And really, when we're talking about those 3 levels of kind of quantum computing, we're really at level 1, as I mentioned, these noisy physical qubits. But when we start getting to level 2 in quantum computing, that's when we start getting these resilient quantum kind of results. And this level we realize with the transition from noisy physical qubits to reliable logical qubits. And we do this by bringing together many physical qubits and applying error connection techniques to form each logical qubit. And then we can create highly reliable systems by combining all of these redundant noisy systems in the same way that today we have reliable communications or reliable storage. The final stage, obviously level 3, is with the logical qubit in place, we'll be able to engineer a scaled, programmable supercomputer with thousands or even millions of logical qubits, which will then be able to solve some of the biggest problems on the planet that classical supercomputers simply are unable to solve for. And over the years, like other quantum hardware developers, Microsoft's built a variety of qubits, including spins and transmons. And we concluded that none of these qubits are perfectly suited to resilience or scale. We need a qubit that's just right, one that's small, less than 10 microns on the side. 1 million of them would then be able to fit on the area of a smart chip on a credit card. So talking about insane scale in terms of size. We need them to be fast, Each operation needs to take less than a microsecond, ensuring that problems can be solved in weeks rather than in decades or centuries. And importantly, they need to be controllable by digital voltage pulses to ensure that a machine with millions of them doesn't require an excessive error rate, or doesn't have an excessive error rate rather. Doesn't require an unattainable input and output kind of bandwidth. These are the key kind of three criteria that we need to meet for a seriously scaled quantum computer. And ultimately, the performance of a supercomputer or a quantum supercomputer will be measured by how reliable the system is at solving real world problems, because that's ultimately what it's all about. And, it needs to be compared directly to how capable and reliable it is versus traditional and classic IT hardware and physical infrastructure. And that is really the key when it comes to quantum. The final kind of pillar, which I kind of alluded to, was this enabling a quantum-ready ecosystem. As we advance to quantum supercomputers, we're simultaneously focused on empowering quantum innovators around the globe to get the most impact out of it. And nobody really should be waiting for a quantum supercomputer to get started. We need experts in chemistry, material science, energy, manufacturing, pharma, to learn more about quantum. We need experts in quantum to learn more about the industry challenges as well, and connect with domain experts to unlock new solutions. So ultimately, we need to grow the community tenfold collectively. And it's going to take the world's collective genius to realize the infinite promise of quantum computing, material scientists and technologists coming together towards a common goal of solving some of the world's biggest challenges. And to gain more insight into this kind of growth path, we partnered with IDC to understand how early enterprise adopters and industry leaders are experimenting with quantum computing and integrating those workloads into their AI and HPC infrastructure. For its analysis, IDC surveyed over 300 line of business decision makers from IT that are currently using AI or HPC compute infrastructure, and understanding what their plan is for the next kind of 2 years, and what their kind of vision is for quantum. And the technology is critical, a critical strategic investment for the future. And enterprise customers are kind of looking for three things: access to the latest and greatest quantum hardware from a single trusted vendor, interoperability with their current HPC and AI infrastructure for a seamless on-ramp to future scale quantum, and also deep quantum expertise and partnerships across a broad and multi-industry kind of ecosystem. And that's when we talk about hybrid. It's unlikely that there's ever going to be fully quantum or fully kind of traditional. There's going to be a mix, leveraging the best of classical computing and quantum computing together. And at Microsoft, we understand that these needs, we understand that quantum computing will be hybrid. Every organization should think of quantum computing as a continuum of their HPC and AI working together to solve business problems in the most effective way. With Azure Quantum, we've ensured that quantum and classical compute integrate seamlessly together, and we've ensured organizations can develop hybrid quantum apps with a mix of classical and quantum code together to run the best quantum hardware, and that is the future of this technology. And just one example of how we've been using or making Azure Quantum the place for innovators, developers, and business leaders is to help them become quantum ready. With Azure Quantum, you can begin building your quantum strategy with confidence and disentangle from the hype, and turn that into practicality for your business. You can accelerate your quantum journey using AI-powered experiences like Copilot in Azure Quantum to help advance your team's coding skills. And importantly, you can assess, test, and improve the right use cases for your business using HPC, AI, and quantum computers in a state-of-the-art cloud platform designed to future-proof your quantum investment. Azure Quantum is the only enterprise cloud that empowers you with your choice. You choose over your code, your hardware, your approach. It's this idea that empowering innovators and developers with flexibility is important and a key motivating force between Azure Quantum. And I think that's a key when we talk about quantum from Azure as a holistic sense. In this spirit of flexibility, choice, and collaboration that drives our kind of vision, reaping the full benefits of quantum will require a collective genius. And it's in these early days that we must shape the future of quantum industry in a way that drives unity, equity, diversity, and impact. And to do that, we need to empower a global, diverse group of people into quantum exploration. At Microsoft, we're committed to removing barriers to entry, creating an ecosystem that's accessible, open, and inclusive. And while it's clear that quantum computing will help solve some of the world's greatest challenges, no single organization, institution, or individual will be able to solve these hard problems alone. And making this happen requires a global community of innovators working together in the service of mankind. And with the advent of any new technology, there are risks that need to be planned and mitigated. And Microsoft's AI principles guide us in quantum. And those fundamental tenets apply to quantum in the same way as they apply to AI. And as we develop new services like Azure Quantum Elements and engineer our first quantum supercomputer, we'll be ready to apply additional measures of rigor, incorporating feedback throughout the process. And if you are interested in kind of quantum safety, I'd highly recommend you check out this blog. We're preparing for a quantum safe future already, as you would expect, and the risks posed by scale quantum computers, such as the ability to break industry encryption, is not imminent, nor is it insurmountable. But the transition to become quantum ready for organizations will be significant. And that's why we recommend with customers to get started now. Microsoft has a comprehensive plan to ensure all of our services remain secure, and we are partnering with our customers and the industry to support them in this important transition. And if you'd like to learn more, there's a great blog by Charlie Bell, which I've just mentioned is the one linked in this chat, who's Executive Vice President of Security, Compliance and Identity, which will go into a little bit more detail when it comes to quantum safety. But the opportunity in front of us is immense. Scientists and businesses will revolutionize the building blocks of everyday products to usher in this new era of innovation and economic growth. We need to reverse climate change. We need better therapeutics. Everyone on the planet has an intrinsic right for access to clean food and water. And we will not be able to collectively solve these problems as a society without technological advancements. And that's what motivates us here at Microsoft. We're working to drive new breakthroughs and empower every organization to achieve more. Together, we can compress the next 250 years of chemistry and material science into the next 25. And that's what we're working to when we talk about Azure Quantum. So I'd like to just say thank you very much for your time today, and also my good friend Vesa for inviting me to the conference. If you're interested in finding out more about quantum and specifically Azure Quantum, please do check out the links on the slide. Ultimately, we're talking about getting people access to the Elements preview, which can be easily searched online. We have blogs and content to get started today, and also there's a $500 quantum credits available for those who want to get started. So thank you very much, and speak to you again soon. Thank you very much.